Hi guys, okay, now we go for the surface integrals for scalar field. So this is the question which you can refer in Dr. Choi's note. Okay, we need to evaluate this integral. Okay, where sigma, okay, is the portion of this plane. Okay, this plane. Okay, lying in the first octant. Okay, we have this integral, we have this plane, and we have first octant. Okay, first octant means that all the axis is positive. Okay, so let's say you can try, okay, when x and y equals to 0, then z will be 1. Therefore, we got like this lah. So when for x, for y and z equals to 0, then x equals to 1. Okay. For x and z, when x and z equals to 0, then y will be 1. Therefore, we got this plane. This is the figure of x plus y plus z equals to 1. So this is in the 2D. Okay. So we will solve this. So, in this question, we got ds. Okay. So, we need to solve the ds. This is the ds. Okay, formula for ds. So, first of all, we solve the z first. So, we make the z as a function. Okay. From here, we make the z as a function. Okay. That will be like this. Then we differentiate z with respect to x, differentiate z with respect to y. Okay, for ds, we just this formula. Okay, so then we substitute lah, del z over del x. Okay, del z over del y. Okay, we solve it, we got this one. Okay, we have, now we get the ds. Okay, ds. Okay, the ds okay, we take this one. Okay, we substitute here. So this is the ds and this is the equation xy. Okay, for these two integral, the outer one, okay, is the integral from point to point. Okay, this one, the inner one, is the integral from the line to the line. Okay. So, how we get this one? Okay, for the dA, it doesn't matter dx, dy or dy, dx, vice versa is okay. So, for dx, so the inner integral, this is the outer, this is the inner. So, the inner integral is integral over dx. Okay, so this one is the line for x. Okay, where we should find the line? From this figure. Okay, so for the line of x, okay, what do we have? So this one, this line segment, this is connect with this x equal to 0 and x equals to 1, the point x equals to 1. So therefore, okay, the first thing line that we meet is x equals to 0. Then it will go until the x equals to 1, reach this line segment. Okay, so this line segment for x equals to y, x equals to 1 minus y. This is the line. So from line x equals to 0 to the line x equals to 1 minus y. Okay. From the line x equals to 0 to the line when x equals to 1 minus y, as we interpret in the figure this just earlier before. Okay. And then for integrate dy, this is the integration of point. Okay, we will integrate from point to point. So this one we need to see the y coordinate y. Okay, so the y from 0 to 1. Okay, zero to 1. So we solve the integration. So this one integrate dx. Okay, so integrate dx, y will be constant. Okay, integrate x will be x squared over 2. Then y will be constant, put it here. This is power root of 3. So this is the number. So this must be constant, then we put it outside the integration. It will be simplified the integration lah. Okay. And then after that, we put the value of x, which from 0 to 1 minus y. Okay. 1 minus y will be substitute into dx. Okay. And then minus, so 0 will be substitute into this equation, then it will become 0. Okay, then we will integrate this equation respect to y. So after we solve this equation, we get this one. So the 1 over 2, I put it outside of the integration. Okay, then we integrate this equation. So this will become just simple integration and we'll get this answer.